The Physics and Astronomy Department at UA really focuses on a lot of different core areas. But I think what they really hit on well is condensed matter physics. They hit on neutrino and dark matter detection. They focus on collider physics. They focus on classic astrophysics and also astronomy as well. By doing that, that allows their faculty, which numbers approximately 30, and there are over 60 graduate students and a whole bevy of undergraduate students, to really attack and define some of the problems of today that are really of interest to scientists and engineers.
The culture of the department is one of the most important things, and I think a real strength for us. And that's at all levels. On the faculty side, it means we actually all get along with each other, and that plays a huge role in our hiring process. We want to hire people that we can work with. And on the student end, it's making sure that student organizations are getting what they need, they meet each other face to face, and basically making it so that it's a place where everybody's happy to walk in the door in the morning.
The collaborative efforts play into this multidisciplinary theme in a very important way, because I work in physics, but if the physics department doesn't have some interaction with the geology department and the biology department and the chemistry department, then we won't be able to provide that broad understanding to students that they actually need.
In 2022, we received from the National Science Foundation a National Research Traineeship Program to create the country's first PhD and master's programs in precision timing. Precision timing, precise time and frequency, these are technologies that are inherently multidisciplinary and interdisciplinary. You need physicists, electrical engineers, aerospace engineers, sometimes chemists, mathematicians, computer scientists. All these folks together, their expertises allow us to build new atomic clocks that can go out into space, that can run our autonomous vehicles, that can allow us to know where we are and when we are. These are all critical technologies.
ACCEPT programs is an NSF NRT funded program, and it stands for Alabama Collaborative for Contemporary Education in Precision Timing. We want to train students in the ACCEPT program who would know how to handle the atomic clocks and what are the basics that are involved in building an atomic clock. The idea is to do basic research to make better and better clocks in order to cater not just the applications that we know of, but also in order to investigate into deeper realms of physics. For example, search of dark matter, and to have deep space navigation when we want to go beyond our solar system. What kind of clocks can we really have that can sustain for such long periods of time? Therefore, in essence, the atomic clock work not just caters the requirement by the physics students, but also engineering, math, and aerospace. So it's an amalgamation of all these kind of niche areas of work at the levels of precision that it would really work.
I teach a rather popular machine learning course on campus, not just to physics students, but also students from other departments. And it's a mixture of foundational and applied machine learning to different fields. And so we cover how machine learning works, how the algorithms works, but also what I've been super excited to see is students who come without any knowledge of machine learning, but come out of the course writing first author papers on machine learning algorithms and applications in their fields. The whole fields are being changed and disrupted right now by this technology. So it's been super exciting to see this growth and see students capable of actually taking those tools and running with that.
A few years ago, I transitioned my research from being purely theoretical particle physics into more using AI, using quantum computing, quantum machine learning. And what I saw here at the University of Alabama is commitment of everybody from the rank and file faculty all the way to the top administration. And not only in terms of words, but actually action and funding these activities that will help us educate the next generation of AI scientists and also do cutting-edge research. My long-term goal is to make the University of Alabama be known as the Quantum AI University and play a leading role, at least among public universities in the US in this direction.
The Condensed Matter Group at the University of Alabama is a young, vibrant community of faculty who are committed long-term to providing excellent instruction for our graduate students, as well as superior research quality. We have a group of faculty that are committed to education at the highest level.